Hey everybody, Dr. Nelson here. This is a video about the commutative property of addition. So for the first few pages, you're going to take notes with me, and then you have a chance to pause the video and try some problems on your own, and then at the end you can see how you did. Alright, so what exactly is the commutative property of addition? Well, maybe you've heard the word commute before, where someone might commute to work and back. Well, the word commutative, I want you to think of, is also associated with the word switch. So let's write the word switch. Or move. Because this property has something to do with moving around numbers. Alright? So the first type of commutative property is the commutative property of addition. And here's the rule right here. It states, okay, when adding two numbers, the order in which the two numbers are added does not change the sum. Alright? So here's an example. Let's say, for example, we have the numbers 6 plus 4. Alright. Well, we know that number 6 plus 4 equals 10, right? So that's the same as if we switch the numbers around, which would be 4 plus 6. All right. Another example could be if we're adding fractions. Let's say 2/3 plus 5/7. Well, that's the same as adding 5/7 plus 2/3. And when all we're doing is adding, you're allowed to move the numbers around like this. All right. So why learn this? Okay. This property will actually save you time. So let's say saves time. And let me give you an example. Okay. Let's say, for example, we have the numbers, say 99 plus 64 plus 1. All right. Now, according to order of operations, we would have to do 99 plus 64, get that number, okay, and then add 1. All right. Maybe you can do it in your head pretty quick. But it would be actually faster if we could add 99 and 1 first together, right? That's 100, and then add the 64. So I can actually switch around the 64 and the 1. So let me change the order. So it's going to be 99 plus 1 plus 64. Now we can simply add 99 and 1, which is 100, plus 64. And we get our final answer of 164. All right? So the commutative property of addition gives you the power to move numbers around. All right? Now, this is really important. I want you to put a big star right here, okay? The commutative property of addition is for only addition. Let's write down only addition. Here's an example of a problem where you could not move things around. Say if I said 8 divided by 2 plus 4, okay? What we couldn't do is move the 4 around or the 8 around, all right? Because now if the division sign was only a plus, then we certainly could move it around. All right, but because we have a division sign in there, that's that. All right, so let's turn the page and let's talk now about the commutative property of multiplication. All right, and this is very similar to the commutative property of addition, except, all right, the rule states that the factors can be multiplied in any order and the product remains the same. That's the rule, okay? So an example of this would be 5 times 3 times 2 equals, okay? How about 5 times 2 times 3? So what I did is I moved around the 3 and the 2, okay? Another example could be, say, 1/4 times 9/5 times 3/4. And because all we're doing is multiplying, I can move the numbers around. I could say this is the same as 3/4 times 1/4 times 9/5. All right. So again, why I learned this? Well, it's the exact same reason as the commutative property of addition. It saves time. And let me give you an example. Okay. Let's say, for example, we have the problem, say 3/4 times 9/5 times 4/3. Okay. Now I could do 3/4 times 9/5 and get that number, okay, and then times it by 4/3. But multiplying 3/4 and 4/3 actually would be a lot easier, right? Because 3/4 times 4/3 is actually 1. So I'm going to change the order around. So it's going to be 3/4 times 4/3 times 9/5. And I know that 3/4 times 4/3 is 1. All right, and then now 1 times 9/5 gives us our answer of 9/5. I'm going to write it over here. It's a little messy, but it's okay. 9/5, and that's it. All right. So when you have the ability to move numbers around, it saves you time. Okay. And again, this is really important. The commutative property of multiplication is only for multiplying. Okay. So only multiplying. All right. You can't mix it up with other operations. So, all right. So an example when this would not work would be something like, say, 6 times 4 plus 2. All right. Because we have a multiplication and addition, okay, it just would not work. All right. All right. So let's turn the page for the last part of this. And what we're going to do is we're going to identify, okay, the equations that are examples of the commutative property of addition and also the commutative property of multiplication. So it says circle the examples of the commutative property of addition and then box in the examples of the commutative property of multiplication. All right. So here we have 5 plus 8 equals 8 plus 5. Well, notice the 5 and the 8s are switching around, right? So that is a good example of the commutative property of addition. So this is we're going to circle that one. Here we have -4 plus 7 equals -4 plus 7. Now notice the order did not change, right? Okay, so that's neither one, so we're going to leave that one blank. 2 times 3 equals 3 times 2. Well, the order switched around, right? It's only multiplication. So this one is the commutative property of multiplication. So let's box that in. Here we have -4 times 2 equals 2 times -4. And again, the order switched around, so that's the commutative property of multiplication. Next one, 1 times 2 times 3 equals 3 times 2 times 1. Looks like the numbers moved around a little bit. Okay, so this is the commutative property of multiplication. Now here we have 8 minus 4 equals 4 minus 8. And notice the operation signs are subtraction, right? So that's going to be neither the commutative property of addition or the commutative property of multiplication. All right, 3 more. -9 plus 12 equals 12 plus -9. And notice we're adding and the numbers that switched around. So this is the commutative property of addition. Here we have 12 minus 4 equals 4 minus 12. Well, notice the numbers did switch around, right? But we're talking about subtraction. So this is neither one. And then finally, 8 divided by 4 equals 4 divided by 8. And again, the numbers did switch around, but we're talking about division, right? And there's no such thing as the commutative property of division. So we're going to leave that one blank as well. All right. So now that you understand a little more about the commutative property, why don't you pause the video and try the Your Turn Now problems. And when you're done, hit play. You can see how you did. All right. Good luck. All right, welcome back. Let's see how to deal with these practice problems. So here again, you had to circle the examples of the commutative property of addition, and you had to box in the examples of the commutative property of multiplication. Well, we had 2 of each. The first 2 here are the examples of the commutative property of addition, and these 2 here are the examples of the commutative property of multiplication. And we actually had 3 that were neither. All right, let's look at why. All right, here we have 8 minus 4 equals 4 minus 8. Okay, and again, because these are subtraction, all right, notice 8 take away 4 is 4, and 4 minus 8 is -4, and this equation is not true anymore because they're not equal, right? So that's why this is not a property. Same thing here, 100 take away 40 is 60, and 40 minus 100 is -60, and again, those are not equal, so it doesn't work. And the same thing with this, because we're dividing, it's neither one of the properties. All right, how'd you do?